We spent the last couple of lectures talking about how we use bits to represent different values in the computer. And we talked about data types and how they determine how we interpret those bits and the operations we can perform on variables of those types. So it's time to actually finally talk about some concrete data types in C#. Before we do, a reminder of the Module 3 learning objectives, still all about data types. And so we're going to talk about, in this lecture, various data types that we can use to represent integer numbers in C#. Before we do, we should talk about an important distinction about the two different kinds of data types we have in C#. And those two kinds are value types and reference types. Reference types are all about classes and objects, which we're going to start learning about next week, so we'll defer a discussion about those for now. Value types are called value types because the bits that are in that memory location associated with the name of the variable actually represent the value of the variable. Now, that may all seem intuitive to you at this point because that's how we talked about it last time, so that's great. We'll see when we get to reference types that it's slightly different, but it's important to have this terminology nailed down. Value types, the memory location is the actual value of the variable. So let's talk about integers. Integers are numbers for which there's no fractional or decimal part. And they include positive and negative numbers, and they include 0. So all the numbers that are non-fractional, non-decimal, positive and negative and 0, are the integers. And in C#, we actually get four different data types we use to represent integers. We get byte, short, int, and long. And the difference between these four different data types is how many bits are used to represent a variable that has that data type. So perhaps not surprisingly, the byte data type uses a byte to store the information. A byte is 8 bits, and so we know from what we've already learned in previous lectures that n equal 2 to the b. So if b is 8, n is 256. So we can represent 256 unique values in a byte. Turns out the range is from 0 to 255. And then we move up to short, which is 16 bits long, int, which is 32 bits long, and long, which is 64 bits long. So because these different data types have different numbers of bits used to represent the number contained in them, we know that that means that the long data type can store a wider range of these numbers than int can compared to short, compared to byte. So that's what we know given these different data types. In this class, we're going to pretty much exclusively use int to represent integer numbers. But if you're in a very memory constrained environment and you are just dealing with small numbers, you might choose short or byte instead to save on memory. Let's look at an actual example of doing this by opening up XNA. And we'll start a new project, continuing with console applications at this point. And I'll say integer, I'll call this new project integer data types. And I am going to zoom in before I forget. I'm also going to add comments. So it's easy for professors as they go through a lecture to say, oh, well, I don't have time to comment, but you always should, so do as I say, not as I do. I'm just going to write the comments, and if you get bored while you watch me do this, you can sort of go to your happy place and come on back when I tell you to. But it's always easier to just skip doing the appropriate thing with the comments, but we're not going to do that. So I'm going to declare both an integer variable and an integer constant. The integer variable, first we start with the data type, and then I'll call it seconds played. I'll even call it total seconds played. So this is how many seconds you've played a game. Give you all of 100 seconds. I'm also going to declare a constant, and the difference is we say const, int, and let's see, seconds per minute. That will be useful to us. So the seconds per minute is a constant because as we run this program, we shouldn't be changing how many seconds there are in a minute. That doesn't make any sense. The total seconds played, we're also not going to change that one as we go along here, but we could. We'll discover later on that we could, ask the user for how many seconds they've played the game so far and so on. So we need that one to be a variable. You'll also notice that I took advantage of that. Optionally, we can in fact provide a value to a variable when we declare it. Constants, we have to provide a value when we declare it. Variables, we can choose to, and I chose to. Okay, so at this point, I have declared these variables. Let me caution you. I've had at least one student do this before. They said, well, you talked and talked and talked about declaring variables, so I forgot. And I went and looked on the web, and I discovered I can do this. I can do var seconds played, and I'll give that a value. And the compiler lets me do it, and I can, it'll all work and everything. Don't do that. For those of you who are familiar with scripting languages like JavaScript or ActionScript, you can not decide on the data type for the variable and let the compiler figure it out and perhaps even change it as you run the program. That's great for scripting languages, but don't do it in C#. Take the time to think about what data type you actually need and then use it. So I'm going to get rid of this because I showed you bad, don't do it, and I don't want to leave it there as an example. Okay, so I said that the operations for integers are largely as you'd expect. We can add things, we can subtract things, we can multiply things. The one area where it may feel unusual to you is when we talk about integer division. So let's actually do some integer division and see how that works. So I'm going to take this information that we have right here, and I'm going to calculate minutes and seconds from it. So I'll have another integer variable called minutes, and instead of putting a literal, this is called a literal because it's literally that number, I'm going to put an expression on the right hand side of this equation, and I'm going to say that the minutes that have been played are the total seconds played divided by the seconds per minute. And let's do some output. I'm going to label the number that I'm printing, so I'm not just printing out a slew of numbers. And so we've seen this console write line printing stuff before, like this, and now I'm going to concatenate. I'm going to slap another string next to this one, and it will be the string that represents the minutes. And I'll add the extra blank line that I like at the end of these programs, and finally I will Control F5 to run it, and we'll see that the result says minutes is 1, and that just doesn't feel right? The minutes should be 1.667 or something. And so this is where integer division is different from the division you might expect to occur. Integer division, division between two integer variables or two integer values, ends up returning just the whole number, not any remainder, if you will. So what if you need the remainder? Well, it turns out that we have an additional operation available to us. So I'm going to calculate seconds, and seconds will be total seconds played, but now I'll say the percent sign in C# means give me the remainder. So what's going to happen now? I'll print those results as well. What happens is we can take advantage of the fact that the integer division only gives us the whole number result, and we have this remainder thing, so that we can in fact Control F5 and see that we can use the way that these integer operations work to sort of extract minutes and seconds from a total seconds value. This is actually really useful. I've used this in multiple pieces of code, including if you keep track of the total milliseconds that somebody plays a game, which is relatively easy to do, particularly in XNA, then you can provide player statistics broken down into millennia, okay, maybe not, at least hours, minutes, and seconds. And so using division and remainder is exactly the way that we go about doing that. I will Control S to make sure I've saved this. And I'm going to browse to the place where I want it to be, of course. This will just take a moment, but it's better to save it than not. So we're definitely in Module 3. Integer data types, this is a good place to save it. Called integer data type, so there we go. Okay. You must be very sad that you haven't done any in-lecture quizzes yet, so now it's time. And this first one is great, so go ahead and do the first in-lecture quiz. You should brag to people that you are essentially doing a college-level course online. And one of the important things you learned in the first week was that 1 + 1 = 2. All right, for people who may not be impressed by that, time to go do another in-lecture quiz. And that one's a little more interesting. So the positive number I gave you in the question is the maximum possible value for an integer. We know this because we have n = 2 to the b, and if we only have 32 bits for an integer, there's a maximum number we can store. And that was the maximum number. When we add 1 to it, because of the way we represent numbers using binary, it actually wraps around to the largest negative number we can store in an int. And so this is something that you may occasionally run into, but it's really interesting. It's an application of n = 2 to the b. To recap, we know that for value types in C#, we store the actual value of the variable in the memory location, and we'll see how that's different for reference types next week. We've also seen that we have 4 different types in C# that let us store integer numbers, and we've sort of messed around with those a little bit to see how they work. Next lecture, we'll actually look at some of the data types that we get in C# for representing real numbers.